Okay, so this is 4.2, big chapter here, or big section, slope of a line. And these notes are online for you. They're going to be posted in Google Classroom. There will be a blank one you can follow along, which I highly encourage, or you could print out a filled in one and follow along with the lecture as well. But the slope of the line, we are going to see this equation, which we have been working with over and over, y equals mx plus b. M is your slope, b is what we call the y-intercept. This is going to be where that line crosses the y-axis. It's going to give me the point, the y-coordinate of where it crosses. My slope, which we're going to define here, is the rate of change. How fast my line rises or falls. Fancy name here. This is an equation of a line in slope intercept form. And we don't get crazy naming these things. It's an equation of a line, and from that equation I can tell slope and I can tell y-intercept. We're going to get into what slope is really heavy today. When you think of slope, I think of a hill, of going up a mountain, and that's exactly what it is. Slope is defined, it's going to be the incline of a line. In this equation here, and we are going to refer to it as m. And this slope, this rise over run, change in y over change in x, things that we're going to be calling this incline of line is measured by m. It's the slope, how fast up or down it goes, and most of the time, all of the time when you're writing this, we're going to want to write it as a fraction. M does equal your rise divided by your run. How fast up I go divided by how fast over I go. My rise, how fast up I go, divided by my run, how far over I go. Rise over run. How fast I go up, divided by how fast I go over. You are going to see us call this, and I'm going to refer to this as change in y, divided by your change in the x. And again, back to my rise over my run. How fast up I go is on the y. How far over I go is on the x. Rise deals with y. It's my change in y over my change in x. I'm going to abbreviate this with a little triangle, and I'm going to write y, a little triangle, and I am going to write x. That little triangle is a Greek letter, delta, and it means change. And if you haven't seen this already in science class, you certainly will. We refer to this as the Greek letter. This is Greek letter delta. Delta means change. You'll see this in science. Delta T, the change in temperature. Delta P, the change in pressure. We're going to call it delta Y, the change in Y, divided by the change in X. When I'm talking about this incline of a line, this slope, this rise over its run, you could have a line that looks like that. I'll label my X and my Y axis. I'm going to make a note here. Read the graph left to right, just like we read a book. I read this graph left to right. I'm looking at this line right here. This line is rising. It has positive slope. This incline is positive. When I read the graph from left to right and my line is increasing or going up, we say that has positive slope. On the flip side, I could have a line that falls when I look at it left to right. If I read this graph left to right, I run into this line. This line is falling. This is negative slope. For positive slope, my line goes up to the right. It rises. In negative slope, simply goes down to the right. One is rising, positive, one is falling, negative. Here we've got a graph of a line, and we are going to find the slope. We are going to find the rate of change. We're going to find the incline. We're going to find out how fast this line goes up and divide it by how fast it goes over, and that's going to tell me the slope or the incline of that line. You've got some points that lie on this line, and when you are given a graph, the easiest way to find the slope of the line is to use your rise over your run. How fast up I go divided by how fast to the right and the left that I go. So I'm going to just count this out. My rise to get from this point here, negative 2, 0, to this point here, 3, 2, I've got to go up and over. Rise over run. To get to that point, I go up 2 and over 1, 2, 3, 4, 5. I have a rise of 2 and a run of 5. And if I look at this, I know right now this has positive slope. Positive slope. It's rising. Rise of 2 in a run of 5. Now I just want to introduce something here that we're going to do as we move forward. I could also go this way. I could start at this point, 3, 2, and get to this point, negative 2, 0. By going that way as well. And I want you to think about something here. If I go down on the y-axis, you are going down 2. That's a negative 2. When you are going left on the x-axis, you are going in the negative direction. That's negative 5. Your rise is negative 2. Your run is negative 5. But a negative divided by a negative is a positive. So I get the exact same thing going in either direction. I just look at this line right here and I know it's going to be positive, and I'm going a rise of 2 and a run of 5. Go on to page 2. We are going to look to find slope a different way too, when we're not given a graph. when we're given 2 points that lie on a line. You will see this in books. You will see this in videos that I send you in the link. y2 minus y1, x2 minus x1. When you are subtracting, you're talking about the change. We're talking about change in y divided by change in x. If my weight is 210 and I get down to 200 pounds, my change in my weight is 10 pounds. How do you get that? You subtract them. If I'm weigh 190 and I go up to 200 pounds, your change in weight is 10. It's still 200 minus 190. We're going to subtract these. Always subtract. I'm going to write this whole thing as change in y over change in x, because that's exactly what we're calculating, the difference of them. And again, this refers to your rise over your run. Rise is on the y-axis, your run is on the x. So here we go in this example. You have 2 points, and I'm going to have to tell you that these 2 points lie on the line. They are 2 points that make up a line. I've got a point, and they're connected. When they lie on that line, because it tells me, I'm telling you they lie on the line, I can find the slope of that line, just given the points, without having to plot these in a coordinate plane and count them out. We're going to get them right from here. Step 1, what you always want to do first, what I'm always going to do is circle your y's. Circle your y's, because I'm going to deal with my numerator here first and my change in y over change in x. I'm going to circle my y's. And remember, we have xy coordinate pairs here. I have an x and I have a y. So if I circle my y's, that's what I got right there. I circled my y's. We are definitely using the formula slope, or m, is equal to change in y over change in x. I circled my y's. Now, step 2, and again, I'm going to do this like a book. From left to right. From left to right, in my order pairs, I'm starting with this one and I'm going to this one. I'm starting with this y and I'm going to this y. I'm going left to right. Subtract, that's the change part. Subtract your y's over or divided by the subtraction, or subtract your x's. And again, you still do it left to right. So here I'm going to work with my y's in my numerator. I'll make my fraction bar because that's my division symbol. Left to right, 3 subtract 2. Divided by your change in x. There's my x's. I have to go left to right again. I cannot go 3 minus 2 and then go 3 minus a minus 2. That's why I'm always going to go left to right. 3 minus 2, so I have to go negative 2 minus 3. I can't go back and forth. I can't make this 3 minus a minus 2. If I went 3 minus a minus 2, my y's would have to be 2 minus 3. I can't switch ordered pairs. Got to go one subtract the other. Now I just do the math. 3 minus 2 is 1. Negative 2 minus 3, negative 5. So my slope, and you'll see the negative written out front by the fraction bar, is negative 1/5. Remember, that negative could be out front here, could be in the numerator, could be in the denominator. We're going to write it out front. Negative 1/5. We're going to try this example. 2 points that lie in a line. You're going to be asked to find the slope. We'll do change in y over change in x, and I'm going back up here. Step 1, circle my y's. Step 2, from left to right, subtract those y's and put it over my x's or divide it. 5, subtract 0. Now I've got to go in this direction again. Negative 2, subtract 2. Notice, minus in both of them. That's a positive, so it became a negative. Now I just do the math. 5 subtract 0 is 5. Negative 2 minus 2, negative 4. You have to check to see if this can be reduced. This can't be reduced. Negative 5/4 cannot be reduced, cannot be simplified. 5 and 4 are prime numbers. The only factors are 1 in itself. That is reduced. So my slope is a negative 5/4. Next example. Change in y over change in x. We're still finding the slope. Go ahead and pause the video. Give this a whirl. Let's see what you got. First step, circle your y's. Subtract them. 1 minus a minus 2 divided by negative 4 minus 1. Yes, you are gonna get negatives because this is always subtraction. You're always gonna, not always, but you are gonna run in the occasion where you have a negative and a negative. You gotta look out for that. Remember, minus minus, I always say slash slash, makes it a positive, makes it addition. 1 plus 2 is 3. Negative 4, subtract 1. Well, I'm at negative 4. I'm going 1 less on that number line. That gives me negative 5. This slope is a negative 3/5. 3 is prime, 5 is prime, that is reduced. I'm going to add one example here. I'm going to say ordered pair 6, negative 2. In the ordered pair, negative 4, negative 6. And they lie on a line. And we want to find the slope. Slope is equal to change in y over change in x. I will circle my y's, making sure to include those negatives. I have a negative 2 minus a minus 6 divided by 6 minus a minus 4. And hopefully you're picking up on why we did this one. Here I've got minus, 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 minus. Minus, minus, slash, slash, minus, minus, slash, slash. Now let's just do the math. Negative 2 plus 6 gives me 4. A 6 plus 4 gives me 10. 4/10. This can be reduced. 4 and 10 are both divisible by 2 because 4 and 10 are both even. I need to reduce that by dividing both by 2. That would give me 2/5. And there's your answer. Just want to show you something what would happen here. I'm going to change this. I'm going to leave this exactly the same, except I'm going to change this 6 to a negative. So I'm going to have the ordered pair -6, -2, and -4, -6. And I'm going to do the exact same thing. Well, my y's are going to be the same. Change in y over change in x. Y's will be the same. -2 minus a -6. Now I've got a -6 minus a -4. Slash, 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 slash. -2 plus 6, still 4, and I should have that. -6 plus 4, -2. This can be reduced as well. 4 divided by -2 gives me a slope of -2. And remember, back at the beginning, I said this slope is usually represented as a fraction, and we can't lose sight as we move forward here that this m could be written as a -2 over 1. And we got to remember that this is a fraction. We don't write it like that, but it could be. Just keep that in mind as we move forward. When we get a slope that's an integer, it's not a fraction, it's not a decimal. It can be written as a fraction. In its whole, we'll put it over a 1. Last thing we are going to look at today is slope of horizontal and vertical lines. So far, we have talked about positive slope, lines that rise. We have talked about negative slope, lines that fall. Now we're going to talk about lines that are horizontal and lines that are vertical, in what sort of slope they have. Back to red. Let's say I have the line y equals 2. Now, if back last section we asked you to make a table and we graphed lines of y equals and x equals, this is a horizontal line going through the point of 2 on the y-axis. You have this line right here. And if we recall back to what we talked about at this line, it does not matter, when I made a table of this, it did not matter what I put in for x. Every y coordinate of every point that lies on the line, its y is 2. The y never changes. Doesn't matter how far out I go in the positive or negative direction on x, y is always going to be 2. Like this, for example, you would have, if I looked right here, you might have the ordered pair -1, 2. You might have this point here, which is 0, 2. I could choose this point here, 2, 2. I could choose this point out here, 4, 2. Doesn't matter what value of x I choose, you should be picking up that your y is always going to be 2. So now I've got some points that lie in this line, and I can certainly do change in y over change in x. Pick 2 points that lie in that line. Doesn't matter which ones I do. I'm going to choose, let's do -1 and 2. I'm going to choose that point. And let's choose 2 and 2. No particular reason. I could have chose any points. Circle your y's and subtract them. There's my y's. And if I notice, your y's are always the same. 2 subtract 2 divided by, subtract my x's, -1, subtract 2. 2 minus 2 is 0 divided by -3. Now when you go to put that in your calculator, hopefully you know that 0 divided by any number is 0. And hopefully you're picking up that it doesn't matter what value, what points I choose on a horizontal line. When you subtract your y's, because those y's are always going to be the same, your numerator will always be 0. Slope of any horizontal line is going to be 0. It's 0. Versus if I look at a vertical line, let's say x equals 2. A vertical line going through 2 on my x-axis right here. The same is going to hold true, everything we just talked about, these y's. You have an infinite number of points that lie on this line. You have the point 2, 2. This is the point 2, 0. This is the point, I'll say right here, 2, negative 4. And if you notice, now your x's are all the same. So if I choose 2 points, let's say 2, 2, and let's say I choose 2, 0, and I do change in y over change in x, and I circle my y's, 2 minus 0 over 2 minus 2, hopefully you're going to pick up and see this pattern. Whenever I have a vertical line, your denominator now will always be 0. If you put that into your calculator, it will tell you an error. It is not 0. We cannot divide by 0. Calculator's not going to do it. This slope we say is undefined. And I'm just going to make a note. In undefined slope, your denominator will be 0. Your denominator will be 0. It's undefined slope. I've got positive slope that rises, negative slope that falls, horizontal slope, which is 0, and vertical slope, which is undefined. 4 types of slopes that I can get from a graph. We also are going to be given tables. We made these tables before. Now we're going to find slope from a table. And remember, when we had an input and we got an output, when we had an x, chose values for x, and we plugged it into some sort of equation or function and got out a y, we were actually making ordered pairs. These are what we made into ordered pairs, and then we graphed the line. We could certainly graph this and do rise over run to find the slope, but that's too much work. We want to just find it given the data points. First thing you are going to do is make ordered pairs. Make ordered pairs. You have this. You have an x of 1 and a y of 8. You have the ordered pair 4, 6. And you have the ordered pair 7, 4. You only need 2 points that lie in a line to find the slope. I've got 3. Doesn't matter which ordered pairs you choose. If they all lie on the line, you can find the slope between any 2 points that lie in the line. So I just need to pick 2 of these, and it doesn't really matter which way I pick them. I'm going to pick any 2 points. Any 2 points that lie in the line. I'm just going to say 4, 6 and 7, 4. You could have certainly chose 1, 8 and 4, 6. You could have chose 1, 8 and 7, 4 as well. Step 3. Use your change in y over your change in x to find your slope. You have 2 points. circle your y's, and subtract them. 6 subtract 4. Divided by 4 minus 7. 6 subtract 4 is 2. 4 minus 7, negative 3. Your slope is a negative 2/3. I want to show you something up here too. And when I'm given a table, you're going to look. We chose x's that had a constant rate of change. We chose x's that were like -2, -1, 0, 1, and 2. Those were all going up by ones. So then we would expect a pattern in our y's. And I do see a pattern right here. It's not going up by ones, but to go from 1 to 4 to 7, there's a definite pattern. You're jumping up by 3. You're going +3. There should be a pattern here because this is linear. I have a constant rate of change, a constant slope. How do I get from 8 to 6? Well, I subtract 2. How do I get from 6 to 4? Well, I subtract 2. The rate of change between these is constant. We know it's a line. And remember, back to our definition, it is change in y over change in x. And if I think about what I'm doing here, aren't I really just calculating my y's and my x's? 6 minus 8, -2, 4 minus 1, +3. And I could choose this point. 4 minus 7, -3, 6 minus 4, +2. Still gives me a -2/3. What you have to look out for when you're counting numbers in the tables, remember, this is my y. It's my numerator. It's second here, but it goes first here. -2 over a +3, and I get the exact same answer. What's easier? I think it's easier just doing change in y over change in x and doing the math right here, because this is exactly what you're doing. When you're subtracting the y's, you're finding the difference between them, you're finding the change. This way, much easier. I'm going to flip over to the last page. And I'm going to do it both ways just to reiterate what we have done today, finding slope. Now again, if you're given a table, look for that constant rate of change. If it's telling you to find the slope, first thing we got to determine is it a line? And if I'm giving you these points and telling you to find the slope, it's going to be a line. But we'll know it's a line if it has a constant rate of change. If my y's change by the same amount, if that difference, that common difference, is the difference the same. How do I get from 1 to 3? Well, I add 2. How do you get from 3 to 5? Well, you add 2. I have a constant rate of change. And again, you're just doing change in y over change in x. To get from 2 to 5, I add 3. To get from 5 to 8, I add 3. The rate of change is constant. I can do change in y over change in x. And again, you are just figuring out what this change is. We're going to do it down here by subtracting our y's. 8 minus 5 is 3, divided by my x. Divided by my x. 5 minus 3 is 2. So my slope is 3/2. We'll call that letter A. Use the table. Use the table. Letter B, I'm going to say use 2 points, just to reiterate what we did before. I'm going to choose 2 points. I've got an ordered pair here, and this time I'm going to go right here. I'm going to choose 2 points that aren't in order, and it shouldn't matter. I can choose any 2 points. I've got the ordered pair 5, 8 and the ordered pair 1, 2. I do the exact same thing we have done on every other problem. I will circle my y's. 8 minus 2 divided by 5, minus 1. 8 minus 2 is 6. 5 minus 1 is 4. I certainly didn't get 6/4 up here. I should get the same thing, but hopefully you notice that 6 and 4 are both even and divisible by 2, which means it can be reduced. And when I divide 6 by 2, I get 3. When I divide 4 by 2, I get 2. And I get the exact same answer of 3/2. And another interesting thing here is if I do 8 minus 2 on the chart, this change is 6. This change is 4. 5 minus 1 is 4. I'm going to get the same thing. I'm just going to have to reduce it in the end. Let's look at one more example. I'm going to make a little XY table. Here's XY. I'm going to say this is 2, 4, 6. And if I asked you to find the slope, first thing you would have to do is say, is this a line? And I'm going to be able to tell if this is a line if I have this constant rate of change. If my x's are increasing by the same and my y's are increasing by the same, or decreasing, because remember it's a common difference. To go from 2 to 4, I add 2. To go from 4 to 6, I add 2. To go from 1 to 3, I add 2. To go from 3 to 6, I add 3. Notice, rate of change is constant. To go from 2 to 4, I add 2. 4 to 6, I add 2. To go from 1 to 3, I add 2, but from 3 to 6, I add 3. This is not a constant rate of change. This isn't a line. This is not a line. No constant rate of change. This is what we call nonlinear. It ain't a line, man. It's nonlinear. It's not a line. We will talk about slope of parallel lines here in another section.